It's not the strongest of the species that survives, not the most intelligent that survives. It is the one that is the most adaptable to change. Said Charles Darwin. It's part of his theory of evolution. Definitely a cornerstone of modern biology. But it's not the only one. As our next speaker states clearly, nothing in biology makes sense except in the light of evolution and Mendelian genetics. Gregor Johann Mendel's scientific and cultural impact, and Nils Christian Stenseth.
Dear friends of Gregor Johann Mendel, ministers, rectors, mayors, academicians and other excellencies, ladies and gentlemen. Thank you very much, Gerald, for a very kind introduction, and to the organizer, Sarkov and colleagues, for inviting me to deliver an opening address at this event. It is indeed my great pleasure to address you on this great occasion of the 200th anniversary of Gregor Johann Mendel's birthday. And I have a hunch that it is today. Nowadays, I typically give three kinds of presentations. I give ordinary science lectures, and since I'm the past president of the Norwegian Academy of Science and Letters, I give dinner tables, speeches, and I give sermons. And every once in a while I combine them. Today, this will be a sermon in honor of Gregor Johann Mendel and evolutionary biology. May I turn to begin with a fact. Nothing in biology makes sense except in the light of Darwinian evolution and Mendelian genetics. And as a matter of fact, it's the first time I'm going to give slides in a setting like this, and I will ask for the first slide. Don't show any slides before I ask for it. Darwin developed a theory of evolution through natural selection, a theory which requires a mechanism for heredity, which Darwin never came to understand. For Darwin, this was a black box, and it worried him till the very end of his life. Mendel was the one that provided such a mechanism, which has come to be known as Mendelian genetics. That's the contribution of Darwin and Mendel, are the cornerstones of modern biology, and in our quest for understand our own nature and the nature around us. Hence, Darwin and Mendel are equals. They're both giants. These are not only my words. These are the words of Andrew Berry and Janet Brownlee, two American biologists and historians of science. Today, the Darwin-Mendel marriage is the foundation of evolutionary biology. Mendel's contribution was not, as is sometimes characterized, the missing jigsaw piece in the complex, sprawling Darwin-dominated scientific puzzle. Rather, a better analogy is lock and key, where each of the two contributions are equally critical to the whole. Within the sciences, Gregor Johann Mendel has played a very important role far beyond the field of genetics. For a long time, far too long, has Mendel been in the shadow of Darwin. In an effort to highlight the importance of Gregor Johann Mendel in modern biology, not the least in modern evolutionary biology, we, Leif Andersson, H.P. Hoekstra, and myself, three evolutionary biologists, have today, this very day, published in the Proceeding of National Academy of Science in US, a collection of 9 newly written papers on Gregor Mendel and modern evolutionary biology. And now I can have the first slide, which I hope I have. This is the front cover of next week's proceeding. And it is an illustration of Mendel's contribution. I'm coming back to that. I'm very happy that proceeding chose to honor Mendel with a cover page. Could I have the next one? And if I have the table of content, the next one. Here we have, in that collection of papers, we have a course about Mendel, a course about Mendel and Darwin, and we have the new synthesis, where Mendel and Darwin was brought together in 1930s. And then we have genetics of adaptation, genetics of domestication, genetics of behavior, genetics of speciation, covering the whole field of evolutionary biology. Now we can leave the slide off for a while. But in this volume, in the introductory chapter, which much of what I'm saying today really is covered, I'm happy to say that Proceeding was willing to include a long footnote by Jiril, the one that introduced me, that provide the arguments in favor of Mendel being born 200 years ago today. We can leave the slide off now. Evolutionary biology is indeed the foundation of modern biology. As we already have heard, the great Russian-American evolutionary biologist Dobzhansky said nothing in biology makes sense except in the light of evolution. We should never forget, though, what the British ecologist Mike Began and colleagues said. Very little in evolution makes sense except in the light of population ecology. It is the ecological interactions, the interaction among living organisms, as well as the effect of the physical environment on living organisms, which determine the selective pressure leading to evolutionary changes. And may I remind you, whenever evolution occurs, the nature of the ecological interactions of coexisting organisms, coexisting species, will in general change, resulting in the nature of evolutionary process changing. Evolution and ecology is indeed a dynamic interaction, interrelationships. Hence, it is correct to say, as the Canadian evolutionary biologist Petlier reminded us, nothing in evolution or ecology makes sense except in the light of the others. During this very exciting time of modern genetics and genomics that we are living through now, this very exciting time of modern genetics and genomics, or if you like, molecular biology, I'd like to remind you, or I'd like to remind everybody here, about what the Hungarian evolutionary biologist Urs Satmari pointed out a few years ago. Not much in molecular life science or genomics makes sense except in the light of ecology and evolution. And I'd like to add, in light of ecology, evolution, and Mendelian genetics. It is indeed a very exciting time to be a biologist today, not the least due to Mendel and the great technological development within the field of genetics and genomics. But, as Urs Schatmari alluded to, this technology-driven biology, as I like to refer to it, must be coupled with profound insight into ecology and evolution, natural history, if you like, the biology of plants and animals out in nature. In On the Origin of Species, Charles Darwin proposed what he called descent with modification. This is what we now refer to as evolution through natural selection. Today we can describe Darwin's ideas as a theory that requires a population of individuals having the following three properties. There will be different reproductive success among the individuals. Each individual produce on average more offspring than is needed to replace itself upon its death, thus typically resulting in competition among individuals for resources. This is the ecological component of Darwin's theory. Inheritance, or heredity if you like, traits that affect an individual's ability to survive and reproduce are transmitted from parents to offspring. This is the genetic component of Darwin. And the third requirement of population of individuals is that there is variation. There is within population variation in this heritability, fitness-related traits. This is the population genetic component of Darwin's theory. As mentioned earlier in this speech, genetics was for Darwin a black box. But Darwin did understand that population with these hereditary properties would evolve when the ecological condition changed. It was Gregor Mendel who came to rescue Darwin's theory of evolution through natural selection. The three laws of Mendelian inheritance is very well known to the geneticists here in the audience, so I need not repeat it for the geneticists. But mayors and governors and the like, I might like to remind you what you learned in school about Mendel. So I do. Mendelian inheritance is generally presented in the form of these following three laws. And we have had alluded to this in the preceding talk. Dominance. Inherited factors can be dominant or recessive. An individual carrying both a dominant and a recessive factor will only show the dominant trait. That's one. Segregation in a diploid organism, such as us, having father and mother, maternal and paternal inherited factors are transmitted randomly to the offspring. And the third one, independent assortment, inherited variants affecting different traits are inherited to the next generation independently of another. Collectively, these three laws replace and explains Darwin's black box, what he needed to make his theory work. Mendel provided the insight about inheritance which Darwin needed to make the evolutionary theory complete. And now we can have the next slide, the Mendel monument. Because incidentally, the Mendel monument, which will soon be found outside here, is a fantastic illustration of Mendel's three laws. Hence, it was chosen by the jury as the winner of the monument competition, a jury I'm happy to say I was part of. This shows a key element in Mendel's contribution on Mendel's 3 laws, the 9:3 to 3:1 ratio. If you don't understand what this, ask one of the geneticists in the audience during the reception, and they will explain to you. Modern biology builds upon, now we can take off the slides here. Modern biology builds upon the marriage of genetics, ecology, and evolution, of which Darwin and Mendel are the main 19th century pillars. And the two, Darwin and Mendel, was brought together in 1930. After, of course, a process up till 1930, but it was in 1930, I think it's right to say, that they really were brought together into the new modern synthesis. Evolutionary biology is today an active field of biology, generating insight not only into the improved understanding of ourselves, but also an improved understanding of the biodiversity around us out in nature. Evolutionary perspectives helps us manage the planet's threatened biodiversity, providing insight into how to achieve sustainable use of the biological resources out there which we all depend on. Both the insight derived from evolutionary biology as such, as well as the approach we use within biology and evolutionary biology, are also highly applicable in practical ways. Evolutionary principles underlie plant and animal breeding programs, which have made it possible to feed 8 billion people that live on this planet today, and possibly may make it possible to feed 10 billion people in the future. Evolutionary thinking helps us furthermore predict where zoonotic diseases, COVID, where zoonotic diseases are most likely to emerge, and predict their spread in time and space. And not the least, predict their evolutionary changes over time. Understanding the evolution of our own species also helps us better understand human nature and health. And there will be several talks during this conference on this very issue. Thus, this century has the potential of becoming the century of biology. The previous century was called the century of physics. This century might become the century of biology, with two main pillars: Darwin's theory of evolution through natural selection and Mendel's genetics, Mendelian genetics. Ladies and gentlemen, friends of Mendel, friends of evolutionary biology, the unifying core of biology, friends of science and the humanities, indeed, friends of what we in this part of the world refers to as Wissenschaft. As my American colleague, the evolutionary biologist, the late Edward Wilson, said, human culture and rituals are not part of human nature, but they are product of human nature. Similarly, art is not part of our nature, but the ability to enjoy and appreciate art is part of human nature, resulting from evolution. Hence, the celebration of Gregor Johann Mendel and the theory of evolution through natural selection is a celebration of science as well as the humanities. Do you remember that Mendel provided a mechanism which made Darwin's theory of natural selection work? Without Mendel's insight, it would simply not work. Thus, do remember that Darwin and Mendel are two equal giants. Thanks for your attention and happy birthday to the celebration of Gregor Johann Mendel. Ladies and gentlemen, let this year be the year when Gregor Johann Mendel come out of the shadow of Charles Darwin. They are indeed both equals. Thank you very much.
Nils Christian Stenseth, thank you very much, Professor. And now we will have a chance to enjoy the concert. Enjoy music of 3 different composers. The choir, Gaudeamus Brno, as well as the organist, Petr Kolář, are ready to perform. The first composer whose work you will have a chance to enjoy is František Musil, Czech composer, music teacher and organist in the Cathedral of St. Peter and Paul in Brno. We are starting with Fugue from Sonata Solemnis.